Hello everyone, welcome back to Deviations. In today's video, we would like to talk about integrating when we have a product of trigonometric and exponential functions. As you know, this is probably going to be one of the more challenging topics that we deal with in integration by parts, but as you'll be able to see, it just takes a little bit of creativity. Let's get started. So in this example, I would like us to try to integrate e to the x times the sine of x dx. Now, it should be mentioned that the trig functions that we're talking about are sine and cos. We should also mention that in our Lyautey convention, we are dealing with trig and exponential. So in the past, this was supposed to be our u, this was supposed to be our dv. So this really doesn't give us many good choices because we are dealing with a trig and an exponential function. Both of these are supposed to be our dv's, but we can't deal with that in this because we have e to the x times sine of x. Okay, so let's do this example, and it's going to be a little bit different from what you might think. So what we do is we actually plug in u to be sine of x. So we pick u as sine of x, we differentiate sine of x, that becomes du, that goes to cosine of x dx. Now dv, by power of deduction, is e to the x dx, meaning that v is also e to the x. So right, we just integrate, e stays the same. Okay, so now let's plug this into our formula. So this gives us e to the x sine of x is equal to, this is equal now to e to the x sine of x minus the integral of e to the x cosine of x dx. All right, now we've got another situation where we've got the exponential times the trig function, so we're going to need to do integration by parts again. Now you're going to be looking at me and saying, what the heck are you thinking of? You're just going to keep doing integration by parts, and it's just going to turn out a mess. You're going to keep getting these sines and these cosines and these e to the x's, and you're always going to be left with an integral that you can't do. Well, you're going to see this is going to be the last integration by parts that we need to do. You're going to see that it is going to be worth it. Okay, so we pick our u to be cosine of x, then our du is negative sine of x dx, then our dv is e to the x dx, and our v is e to the x. All right, well now what I'm going to do is I'm going to plug this in, and notice how I write here that we have the integral of e to the x sine of x on this side. That's going to be important in a minute. So we have the integral of e to the x sine of x is equal to e to the x sine of x minus e to the x cosine of x minus the integral of e to the x sine of x. So now let's attach some dx's onto here. And what we've noticed is that these are the same. We've got two e to the x sine of x's. Now they're not going to cancel each other out, but what if we were to add this guy onto that guy? Then we're going to be left with all integrals on one side and all functions that have been integrated by parts on the other side. Okay, so let's have a look at this. So I'm going to rewrite this so that it's not covered by the red pen. But this says that 2 times the integral of e to the x sine of x dx is equal to e to the x, we factor out an e to the x, sine of x minus cosine of x. Okay, well now this looks good. We've got something here, which is kind of an answer. And we've got our original problem question, which was the integral of e to the x sine of x dx. Now we've just got this constant 2 tacked on the end. So actually what we can do is we can just divide everything by 2, and that's going to give us the integral of e to the x sine of x on one side is equal to something else. So let's do that. So this gives us the integral of e to the x sine of x dx is equal to 1/2 e to the x times sine of x minus cosine of x plus c. Look at this, ta-da, we've got an answer. And this is completely valid. So the integral here of these two functions that can be integrated and differentiated infinitely, and we've turned that into something that we can determine with that cool trick where we just do that subtraction with that algebra. So I think that was pretty cool. And it can be done with cosine as well. It's a very helpful tool that we deal with here. So in the next video, we are going to be moving away from integration by parts, and we're going to start talking about the trigonometric reduction formulas, which have a little bit to do with integration by parts. So the way that we're going to be dealing with this trig section, so I'll just give you the roadmap for the rest of Unit 6, basically, for analytic methods. So we are going to be talking first, after this, about the trigonometric reduction, which has a little bit to do with integration by parts. Then we'll be talking about trigonometric integrals, and that's when I have like the integral of sine of x to the fourth times cosine of x to the fourth, or something like that, where we have these trig functions with powers, and we use those identities to determine. Then we do something with called trigonometric substitution, and that's something that's pretty interesting, and that allows us to deal with radical functions. So we'll talk about that later. Then we'll also be talking about the Weierstrass substitution method that allows us to deal with some more trigonometric functions. It allows us to derive the integral of, say, cosecant pretty easily. And then we are going to be moving to some more algebraic ideas. We're going to talk about partial fractions, which deals with rational functions. Then we're also going to be dealing with inverse function integration, so that there's a nice formula for that. Then we're also going to be talking about some Feynman integration, which is a little bit of a dive into something called variational calculus, but we're not going to be going too deep into that. And after that, we're going to be talking about some numerical methods, and that's going to be like Simpson's rule and also some improper integrals. So that's really what we'll be talking about. So thank you so much for watching, and we will be back in the next video to introduce trigonometric reduction.